high noon, 12 o'clock, last of the 3 IODP media conferences. It's another conference about an expedition, of a European expedition within IODP. It's the Great Barrier Reef expedition, which was carried out only a couple of weeks ago. And 2 colleagues will inform you about this challenging project, namely Dave McInroy, who you already know. He's from BGS in Edinburgh, British Geological Survey, geoscientist, as is my colleague Alan Stevenson. He's also located in Edinburgh. He's ECORD Outreach Manager, and ECORD again stands for European Consortium for Ocean Research Drilling. So I think, Dave, you will give us an overview first, and the floor is yours, please.
Okay, thanks. One thing I should point out first is that I'm not a coral specialist. I'm also not a climatologist or a climate change specialist. I'm actually a geophysicist, so I apologise in advance if I can't answer your scientific questions to the depth that you might expect.
But may I interrupt you? But we have a coral specialist here, Gilbert Camoin. He's sitting there. He led the parallel expedition in 2006 to Tahiti. So you can ask any question about corals and coral assemblages and so on and so on. Okay. Sorry for interrupting.
But both Alan and myself were involved in the planning of this expedition. So what I'll do now is just give you some details of how that went. So this was IDP Expedition 325, Great Barrier Reef Environmental Changes. It took place from the 11th of February to the 6th of April earlier on this year, and lasted for 55 days, and headed out from and returned to Townsville on northeastern Australia. The ship that we used was called the Great Ship Maya. We had to contract a company called Bluestone to provide the drill rig and the drilling team and the vessel. It is the nature of mission-specific platforms that we contract these vessels on a case-by-case basis. And for this work on the Great Barrier Reef, we needed a dynamically positioned vessel. We weren't able to use anchors to hold the vessel in position while we were working, so the DP thrusters on the ship had to be of a sufficient capacity to hold the vessel in place, even in strong currents and with quite high swell. And all of this was overseen by our own drilling coordinators from the ECORD science operator. So on board, well, first of all, every expedition in IODP has a science party, which consists of up to 28 scientists from around the world. You can see them all listed here. The names I've highlighted in yellow were the scientists who actually sailed on the ship. So a mixture of coral specialists and petrophysicists and paleomagnetic specialists. And we also had some geochemistry technicians who were not part of the science party but were supplied by the ECORD science operator. And this entire science party will meet in Bremen on July the 2nd this year to work on the cores, split them open and do an initial description and initial measurements. And then they'll take samples as well. And then at their own institutes in the coming years, they will work up on their own post-expedition science, which they'll publish in peer-reviewed journals in a couple of years' time. So where did the expedition go? They visited 4 transects on the Great Barrier Reef, offshore northeastern Australia. 2 transects in a region called Hydrographer's Passage, one at Noggin Pass and one at Ribbon Reef. And the aim was to recover cores of ancient coral reef material that contain records of past sea level and climate changes. I'd just like to emphasise that what we were targeting was ancient coral reef. We're not interested in modern corals, so we took great pains to avoid damaging any of the modern coral cover. It's not what we're interested in. We want these drowned reefs, which are now dead coral skeletons. And a few statistics. We visited 29 sites in total and cored at 34 holes, retrieving 420 cores. We drilled a total length of nearly 760 metres and recovered 225 metres of core. So that was an average recovery of 30%, which was a little less than we had hoped. At our partner expedition that we did in 2005 offshore Tahiti, we achieved 60%. But offshore Great Barrier Reef, the lithologies were slightly different. They were slightly looser and made it a bit more difficult to recover the material. But despite the lower than expected recovery, we did still manage to recover over 200 metres of core, and some of these pieces contain nice massive coral colonies, which are indicative of high energy shallow water environments, and these make them perfect for reconstructing sea level change. So in a little bit more detail, the scientific objectives of the expedition. The first one is to establish the course of sea level rise during the last deglaciation, so that's between 20,000 and 10,000 years ago. 20,000 years ago, at the peak of the last glaciation, sea level was about 120 metres lower than it is at the present day, and since then it has risen, not following a smooth curve. It's risen in a kind of sawtooth pattern, so there's been minor drops and accelerated rises throughout that general rise over the last 20,000 years. The second objective was to reconstruct the nature and magnitude of the seasonal to millennial scale climate variability. So that's looking at the sea surface temperature and the salinity. So these measurements can be made on the skeletons of the corals. If we do geochemical analysis on the coral skeletons, we can reconstruct what the sea surface temperature was and how salty the water was over the last 20,000 years. And the third objective was to determine the biologic and geologic response of the Great Barrier Reef to abrupt sea level change and climate change. So that's how the corals coped with the sea level rise. As the reefs drowned, what species suffered the most, what fared a little bit better, where did they move to? And this is very important, not only just for the Great Barrier Reef at a local level, but also at a global level. It's important for other reefs around the world. So anyone who's interested in reef management would be interested in the results from this final objective. So there were two areas chosen to do these studies. The first area was offshore Tahiti, on the fringing reefs around Tahiti. That expedition was completed in 2005 and 2006. And the expedition that I'm talking about now, the Great Barrier Reef, was completed just a matter of weeks ago. So why do we choose Tahiti and the Great Barrier Reef for this work? Well, for the sea level changes story, these two regions are tectonically stable, and they are in areas where the vertical movements are slow and are regular. So Tahiti is a volcanic edifice, volcanic island in the middle of the Pacific, and the Great Barrier Reef is on a continental margin, and both of these are quite tectonically stable areas. There's no influence from other tectonics like subduction or uplift due to mountain building, which might have another imprint on the sea level curve in that region. They're also both far from former ice sheet margins, what we call far-field sites. So these regions will avoid any vertical movement due to the addition and the removal of the weight of ice. So it's important that these two regions that we chose were far from these ice margins. For the climate variability story, we know that the tropical Pacific Ocean plays an important role in driving and modulating global climate variability and change in a wide range of timescales. So the fact that both these sites are in the Pacific was quite important, and that's why these regions were chosen. So why is this expedition relevant? Why do we bother doing this at all? Well, I think the first point here is probably the most important, that to make accurate predictions about future sea level and climate change, we must consider the archives from the past. And this first point has global relevance. This is important. And if people are going to do future modelling, future climate modelling, or climate change modelling, or future sea level change modelling, then they'll need to use the records from Tahiti and Great Barrier Reef as input into their models to make them valid. It's also important for us to directly test how the Great Barrier Reef and, in fact, other reefs around the world have responded to past rising sea levels. So we have these events called meltwater pulses, where continental ice rapidly melted and injected a lot of fresh water into the oceans, which not only raise sea level, but it also changes the thermohaline circulation, the transport of heat around the oceans, and that changes the Earth's climate. Also, how does the Great Barrier Reef respond to the changing sea surface temperatures? How does it change to the changing sediment input, the runoff from the Australian mainland? And how do the reefs cope with the changing ocean chemistry? For example, the pH. So it's also relevant because this expedition will provide information on the coral growth rates, how quickly the corals grew, how the communities are made up, what species make up the communities, and how those have varied through time in response to sea level rise, and how the geometry and the shape of the reef has changed in response to these sea level changes. And also the last point, very important, is to establish environmental thresholds at which coral reefs die and are able to re-establish themselves. So how fast does the sea level have to rise before a reef drowns and can't re-establish itself somewhere closer to the coastline? So I've mentioned this previously. This was an expedition that we did in 2005, Tahiti sea level, which was the sister expedition to the Great Barrier Reef, and there's now some interesting results emerging from that expedition, appearing in the scientific press. And if you want to know more about that, there's also a publications website where you can visit and read the expedition report from our expedition, but also lists all the scientific papers that have been published based on the Tahiti results. And we're fortunate to have Gilbert Camwan in the audience here. He was co-chief scientist for that expedition, so he can help answer some general questions about the science. I know this press conference is about the Great Barrier Reef, not Tahiti. Okay, so to look at the operation then in a bit more detail, this slide shows a picture of the great ship Maya in Singapore on the 5th of January this year. This is us mobilising the ship. But not only did we have to mobilise the ship, we had to build the drilling infrastructure from scratch, and we contracted this company Bluestone to do that work for us. And you can see in a relatively short period of time, here's the 11th of February, leaving Townsville, the ship has been transformed into a brand new working drill ship heading out to the first site to start collecting core. And this slide really is a statement of what MSPs are all about and what we're involved in. We take ships and we turn them into drill ships based on the scientific requirements of the proposal that we're trying to address. We're also armed with, the expedition was also armed with a collection of site survey data. So this data was collected before, in the years leading up to the expedition, by the proponents, and it includes data such as multi-beam seabed data, which is basically a detailed 3D map of the seabed, which picks out the drowned reefs and terraces that the expedition targeted. This is a 2D seismic line across the reef terraces that the expedition targeted, and this slide demonstrates quite clearly what the expedition was targeting. Here we can see these reef terraces quite clearly, and you can see how they're backstepping towards the coast. The coast is in this direction, and you can see that when this reef was alive and growing, sea level would be roughly in that position. Sea level is now at the top of the section. That's where current sea level is. And you can see how as sea level has risen, the reef has stepped back, and eventually sea level rise has outstripped the reef's ability to keep pace, and the reef is now drowned and is now dead. And the living reef will be somewhere else nearby, probably further in this direction up into shallower water. Okay. Here's some pictures of the operation. Here's the ship on station. Like I say, it's dynamically positioned, so there's no footprint on the seabed at all, apart from where the drill string enters the seabed. Here's the moon pool, where the drill string goes down into the quite beautiful waters of the Great Barrier Reef. And here is the typical core barrel that we used in the expedition. So this core barrel is deployed down the drill string. Inside here is a plastic liner, which the core slides into as it's cut out from the ancient reef, and then we pull the core barrel back to the ship via a wire line, and then we unload the core on deck where a few initial measurements are made, and then the core is curated and it's put into refrigerated storage. Here's some of the scientists looking quite cheerful because this was a good run. We've got some nice pieces of coral core back, and you can see this is it here, held in its plastic liner. And that's as much as the scientists will get to see at this stage. They can do a preliminary description through the liner. They'll have to wait until July the 2nd in Bremen before we slice these cores in half, and then they can have a much closer look without having to look through the semi-opaque liner. So yes, the next step is the onshore science party in Bremen. These are pictures from the Tahiti science party, which took place in 2006. These are the two co-chiefs for Great Barrier Reef. They just happen to be scientists as well on the Tahiti expedition, Jodie Webster and Yusuke Yokoyama. And at this stage, the full analysis on the cores will take place, and that starts on the 2nd of July. The cores are currently in transit on their way to Bremen. So that's all I wanted to say about the expedition just now. If you want further information, we can answer some questions now, but if you want more detailed information, I should encourage you to contact either the co-chiefs, Jodie Webster or Yusuke Yokoyama, their email addresses are there, or the staff scientist who was on board, Carol Cotterill, who works at the BGS. And there's also an expedition website which contains the scientific prospectus, the daily reports from the expedition, the list of participants, and in probably late September time, a preliminary report will be published on there as well.
Yeah, and in the media pack, in the media kit, you find Alan's and my business cards. So if you need any further information, just drop us a line, send us a mail. I just handed out to you in a second. Sorry, I'm a little bit late. As Dave already pointed out, it takes quite a long time to prepare such an expedition. And I think, Alan, you have been to Townsville a couple of times to help to get that running, that project running. Can you tell a little bit of what you have to have in mind to, except from pre-site survey, as Dave already pointed out, what you have to have in mind to prepare such a project?
Sure, yeah. Well, as we don't have very many results to present to you after the Great Barrier Reef because it's just finished and it will be a few months before the scientists do the real work, we just thought we'd take this opportunity to emphasize how important outreach around these activities is for us, and of course, and I guess to thank you for your interest in the programme. If you were here for the press conference about the future of IODP, you heard the speakers talk a lot about engaging the scientific community to ensure that the programme has a future, but also engaging the public is important for us in making sure that the programme has a future. And really the only way for us to do that in large numbers is through the press and the media. So of course it's important to us that we have these events and that you come along and take an interest, so thank you for that. And as Albert has said, in the build-up to an expedition that could be quite sensitive, such as the Great Barrier Reef expedition, I think it was brought home to me at an early stage during the planning when someone said to me, when we said we were going to be drilling in the Great Barrier Reef, they said, well, that's a bit like putting a telephone mast in the Taj Mahal. That's how the public are going to perceive, what you're doing, because this is a great icon for Australia, and you're saying you're going along there and you're going to drill. And of course, to make sure that we don't make any mistakes in the whole process, we work very closely with the Marine Park Authority. The Great Barrier Reef Marine Park Authority are responsible for the reef. And although, as Dave has emphasised, we weren't anywhere near the modern day reef perception. That we're in the area and we're drilling corals. It could be that we were drilling. Through the modern reef. So we had to make it clear to people that we were drilling through fossil reefs, and we had to get that message across. As I said to a few people when we were doing the expedition, we just wouldn't have been there if we hadn't been doing the right things. And we worked very closely with the GBRMP. And we also took the opportunity, because they obviously have a number of outlets in the area. Their own headquarters is based in something called Reef HQ in Townsville, and they have one of these aquarium events, or it's not the right word, but you know what I mean, where you can go through the tunnel and you can watch the sharks and so on. And we put some posters in there explaining what we were doing, and that's a big tourist attraction in Townsville. Everyone that goes to Townsville goes to Reef HQ. So anyone who, and we aimed it at more for the sort of children that would be visiting the centre. We would like to have done more, but everything has a limit because of resource. On the website, we used things like Facebook and Twitter, sort of to try and engage a younger audience as well. That was the first time we tried that with an expedition website, and that seems to have been very successful. Somebody made the point that last night at the town hall meeting, we had a very large number of young people, and that possibly that was because we were engaging people through some of these more kind of the social media more than we have done in the past. So it takes a lot of planning, and the fact that we've been there and we didn't have any real problems. I think one time we had a report that there was a cruise boat gone out from Cairns, and they'd seen the vessel and they thought we were drilling for oil. And of course, it was very easy to tell them that we were not doing that because the permitting process, clearly emphasises that that's not what we're interested in. But you can understand why people might look at these things and think that way. So it's a big job to make sure that public perception is correct, and we thank you for helping us with that.
All right, thanks lots. So any question concerning science or logistics or anything like that from your side? As mentioned before, Gilbert is here also to answer questions if they are specific. So if not, if you're just thinking, I would just point out about difficulties. At one time, I think you had bad weather, and that was it, I think. But this was really bad weather, wasn't it, Dave? Can you tell about that?
Yeah, there was the expedition was affected by a slow-moving typhoon, which moved to the north of the project area, and it whipped up quite a swell, which was too much for the ship to handle. So it was the ship had to come back into the more protected areas, the more sheltered areas, just to wait out the weather. So yeah, that events like that do have an effect on our expeditions. We have weather downtime quite often, and it's especially when you're working from a vessel such as this that only has a certain amount of heave compensation. It can only work, I think, in 2.5 meters swell. This one, I think in Tahiti, it was 5 meters swell. And if it exceeds that, you just have to stop. There's nothing else you can do. It's just not safe to continue. So yeah, it can be quite tough for the participants on board during those periods.
All right. Right. Then if you don't have any questions, any further questions, I think participants and also Gilbert are here for further personal questions if you would like to have personal interviews for the radio or so. And if there are no more questions, then I would like to thank you for participation in all these 3 media conferences, and especially in this one. And I would also like to thank Dave and Ellen very much. Thanks a lot. Okay.
Thanks.
Thank you.